and then I'll let we move on. It says, here's the condition. F prime of x is less than 0 for x less than 0. F prime of x is greater than 0 for x greater than 0. All right, here's another condition. F double prime of x is less than 0 for the absolute value of x is greater than 2. This is, I was worried that this notation may stress you out. The absolute value of x greater than 2, this means x is greater than 2 or x is less than negative 2. Do you remember that from maybe algebra 2? The absolute value when you have the greater than is an or expression. You switch the symbol and the sign. Okay, so, and then the second derivative of x is greater than 0 for absolute value of x less than 2. That means that you have a sandwich between -2 and 2. Your second derivative is positive. Have y'all seen that notation for absolute value? Do you remember that? Just wanted to make sure you remember that, what that notation means. Because then this isn't going to be too bad. What do we know about the function? Well, let's just draw some things. Here's f prime. At 0, we have a change. The function, the derivative is negative for x is less than 0 and then positive. So that tells you that f is decreasing and then increasing. So if you're decreasing and then increasing, you have a min at 0. And what does the second derivative tell us? Well, the critical points on, or the points of inflection, possible points of inflection for the second derivative seem to be at -2 and 2. And it is positive in between -2 and 2 and negative on the outsides. So the original function f is concave up, concave down, and then concave up. So what you could do then, if you want to sketch a possible graph, you have no idea where these points are, but you know that you have a min at 0. So like you could just draw, I don't know, at 0 you could draw a min. You know you have a min, right? At -2, and you don't know where, but maybe here, and then also at 2, you have points of inflection. You're going to change from concave, gosh, I did it. Again, this is concave down, concave up, concave down. You're going to change from concave down to concave up at -2. So you're going to go kind of, all you know is that it has a little change in concavity. So it's concave down, and then it's concave up. And it stays concave up, and then at 2 it's going to change from concave up to concave down. So it looks something like that. So that could be your possible graph of that. So expect something like that on the test. It's not really that hard, but it definitely tests that you understand the different roles of the derivatives on how to sketch the graph. Okay, other questions?
Did you do 54 from the second column here?
Sketch the graph, noting the transition points and the asymptotic behavior.